Hello and welcome back to my channel. Today we are continuing learning more about chemistry. This is the 7th video of the 12 video series, and I'll be leaving all previous video links in the description below, so check it out. Today I'll be talking about stoichiometry, and this is going to be the first video, and I'm going to give an example. I'll be posting another stoichiometry example soon. So let's do some stoichiometry. First we're going to do a normal balancing equation so we can practice. So we're going to start with iron 3 oxide plus aluminium produces aluminium to oxygen 3 plus iron. So with a stoichiometry question, you'll always start with an equation, and I think it's better if we practice our balancing equations. So first let's look at the iron. On the left we have 2, but on the right we only have 1, and because on the right it's a single atom, we can just put a 2 in front of it and it's done. Now let's look at the oxygen. On the left we have 3, on the right we have 3, so that's balanced. That's good. And then we can look at the aluminium. On the left we have 1, on the right we have 2, but it's a individual aluminium atom, so we can just pop a 2 in front of it, and there we have a balanced equation. And now for the stoichiometry. So think about stoichiometry as if you have X grams of this reactant, how many grams would you have of the product? So let's say we are given 85 grams of iron 3 oxide, and we need to work out how many grams of aluminium we need. When you look at the equation, you can see that a mole ratio, so how many moles of this molecule of iron 3 oxide, we need 2 moles of aluminium, because there's only 1 mole, as you can see, and then there's a 2 for the aluminium. So what we need to do is find out how many moles of iron 3 oxide we need, and then we have 2 moles of aluminium, so we can work out how many grams of aluminium we need. So first we have 2 iron atoms and 3 oxygen atoms. So iron's atomic mass is 55 or 56, so we have 2 iron atoms, so we times it by 2, and the total iron atoms is 112 grams. And we have 3 oxygen atoms, each in 16 grams, so that's 48 grams in total. So let me work out the atomic mass of the whole compound, and that is, the atomic mass of it is 160 grams. So we started off this reaction with 85 grams of iron 3 oxide, and to work out the number of moles, we need to work out 85 grams divided by 160 grams per mole, which is the AMU of iron 3 oxide, and that would make 85 of 160 moles is 0.531 moles of iron 3 oxide. And as we know, the mole ratio is 2 to 1 because the aluminium has the 2 before it, and it's the mole ratio. We must times 0.531 or 0.53 moles by 2, or 2 over 1 because the mole ratio, and now we know we have 1.06 moles of aluminium. So we worked out the moles of aluminium. Now we're going to try and work out the amount of grams that we need. Now we need to work out the total atomic mass of the 2 aluminium atoms. So 1 atom of aluminium has an atomic mass of 27, and if you think we need to times it by 2, we actually don't, because we've already done the mole ratio. So to work out the number of grams we need, we do 1.06 moles of aluminium times the 27 grams, the AMU of it, and that would give us 28.62 grams of aluminium. And there we have it. That is how you work out how many grams of aluminium you need in a reaction of 85 grams of iron 3 oxide. Thank you for watching. I hope you liked the video, and if you did, don't forget to like and subscribe. See you in the next one.